Okay, this video shows you how to create the jump output using the ceramics data as an example. So you first download the ceramics jump file on canvas and then double click. You'll get this table. There are two columns. One column is pressure and another column is the density. So what you do is you click on the analyze, because then you click on the fit y by x, because now you only have one x. Then you select the pressure. Pressure is the predictor, so we click x factor here. And then the density is the response variable, so you click on y response, and then you click on OK. Then you will see a scatter plot like this. Next, you will click on the red triangle here, then you select fit line. Then a line is fitted. There is the fitted line with the estimated intercept and estimated slope. And we have the summary of fit. The R squared is 98%. And this root mean square error is just the SLF. And the mean response is the Y bar. 15 observations is the sample size N. And here we have the ANOVA table, and we have the preliminary estimates table. And in the preliminary estimates table, you have the estimated intercept B0 and the estimated slope B1. And you have the standard errors of B0 and B1. And the T ratio is just the estimated B1 divided by the standard error of B1. You got a T ratio. And this T ratio is used when you do a hypothesis testing to test whether the true slope is 0 or not. And this is the p-value for that two-sided test. And we can see that the p-value here is small, so we can reject the null hypothesis and conclude that the true slope is different from 0. And this method, fit y by x method, can only be used when you only have one predictor. So if you have multiple predictors, I also linked another video for using JMP to do the linear regression with multiple predictors. And in that one you use the fit model instead of fit y by x. And another thing is that once you have fitted a linear regression, you can click on this red triangle on the linear fit here, and you can go to save residuals. Okay, and then once you have saved the residuals, you will see that there is a new column created, which is the residuals yi minus hat yi. That is just the EI, the raw residues. And you can also save the studentized residues. Then another new column will be created, and you will see the studentized residues. And if you want to make the residual plot, you can use the graph builder. First, click on the graph and click on the graph builder. For example, if you want to get the studentized residues, so you drag the studentized residual density column to Y here, and you want to plot the studentized residuals against the predictor X, and then drag the pressure here. And we don't need the curve here, so you need to uncheck this. And now you get a scatter plot. But most of the time, you are interested in checking whether the residues are evenly distributed around the horizontal line y equals 0. So you want to add a line that y equals 0. So what you can do is you right click on the graph and click on the customize, and you want to click on the add a new script, and under that you use click on template y function. So in the y function you change this part, function of x, to 0. Okay, then you get a y function. Click on OK. Then you get a horizontal line. And if you want to change the color, go to the script you just created. You can change it by using pen color. So by default, pen color is blue. Yeah. So if you change it blue, then the line will be blue. But if you want to change it to something else, something like red, you can just change the blue to red. Then you get a residual plot of studentized residual against the predictor X. In this case, it's pressure. And you also have a reference line, which is y equals 0, to check if the residues are evenly distributed around the line, because we assume that the residuals should be normal random variables. It is normal random errors around 0. And now if you want to save this plot, you can right click and click on edit, and you can select copy graph. Then you can go to a Word file, do the paste. You can use the Control V to paste it. Then you got this residual plot. And you can also do the same thing in the jump output page. So for example, if you want to save this, you can right click on the graph and edit, copy graph. Then in the Word file, just to Control V and then you get the regression line plot of density against the pressure. And there is a lot of other options you can change. For example, you can change the line color, line style, line width. You can also save the predicted Y. And there are some options for creating the confidence intervals. They are called confident confid curves fit or and confid curves in diff, and this is the confidence intervals for Y, for an individual new observation Y, and this confidence curves fit is the confidence band for the whole regression line, and we will talk about this later in the next lecture. And let's see what else do we need to. So if you want to create a quantile plot, it's like if you use this fit y by x method, I think you don't have such an option to give you a quantile plot of the residues. But you can do a quantile plot if you use fit model. So what you do is click on Analyze and click on the fit model, and you put the density to Y and the pressure to the construct model effects to X, and the emphasis is effect leverage, and the personality is standard least squares, and click on Run. This leverage plot is not of interest and will not be covered in the class. And in this method, you can also find the regression plot, and you can also get actual by predict plot. So in this actual by predict plot, you get the actual y's and the predict y's. So it's y against y hat. You also have the ANOVA table here, and there is a residual by predict plot, so that it is the raw residual against y hat. And there is also summary of fit the